Okay, anybody know what trigonometry is? What is trigonometry? That's it. Trig, I mean, it's the study of triangles. Alright, so trigonometry is the study of triangles. There it is. Now, man, that sounds pretty simple. You go, okay, they got 180 degrees and 3 sides. We're done. A lot more to it than that. Alright, so to get into trigonometry, we need to review some geometry. Just some basics. You already know this stuff. But a lot of what geometry has happened in it is these three situations right here. Now, obviously, there's a lot more to this, but this is one of the most frequent. And when you get into situations like this, this is where we are going to form triangles out of a lot of situations like this. In the middle of trig, you're going to have a bunch of stuff that looks like this, and you got to form a bunch of triangles and understand the properties that are going on there. So, when you set up an algebra equation from a geometric situation, that's why you learn algebra first. You take that to geometry. It puts the algebra in with shapes. The next progression is we go to trigonometry, and we learn things that are going on there. And then calculus is the application of algebra, geometry, and trigonometry. It puts it all together that we apply it all in calculus. Alright, so here you go. First up, they are equal. There's a common setup of algebra in a geometric situation. So, 1, 2, or 3, which one of those has where the x is that you set it equal? Is it the first one, the second one, or the third one? First one. Alright, you put a big equal sign right in the middle there, that 5x is equal to x plus 100. That's the situation where they are equal. Okay? You set up an equation to find x there. Your equation is 5x equals x plus 100. And now comes complete Algebra 1 background that you can solve for x. Now, I do want to state one other thing with this. I want you to know some specific terms with this. Number one, what is it called when it's dealing with shapes and not numbers? Equal is when numbers are equal. But when it's shape, how do you say that this shape is the same as that shape? Congruent. Very good. So under equal, put congruent. Alright, congruent. Now let's go ahead and solve that. Complete background. I know you guys can do that quickly. As far as work goes with algebra, guys, whatever you need to show. I know that we're to the point now after algebra, pre-AP algebra 1, pre-AP geometry, pre-AP algebra 2. You don't have to write minus 1x, divided by 4. Whatever you need to show. You can, and by any means, whatever you're comfortable with. However you want to show that. X is 25. Alright, now notice, is that the answer to this question? Alright, a star by that. Alright, this happens a bunch on the ACT, this happens a bunch in trig and calculus. You need to know some algebra or geometric properties. You need to use algebra to solve for something, but then you need to use that answer and plug it back in to actually answer their question. If I want to find angle RST, that is this angle right here. It is 5 times, now I know the value of x is 25, 5 times 25 is 125. So it's a 125 degree angle right there. Okay? And again, I'm going to be very flexible at this stage in the game and how you state that. Yes, it's absolutely fine to say something like the measure of angle RST equals 125 degrees, but in all honesty, if you put 125 right in here, we're going to say that's fine. This is not a point where your format is going to be a huge deal. This is, let's review and let's move on quickly, okay? So a different goal than we got to write it this way and I'm checking for this. In the beginning of the year, though, it's always a question of how much work do I got to show? How do I need to label my answers? Right now, we're pretty flexible. All right, second one. Other thing that can happen a whole bunch in geometry is you add to 90. Which one of those situations is that? Second or third? Wow, I go right in a row here. Yeah, second. With that, again, there's a special name for it in geometry. What's that called when something adds to 90? Oh, you got this.
Give me a second.
Alright, how can we remember the difference between the two? Here's a real simple and easy way. This makes a corner. What letter does corner start with? C, complementary. Complementary corner, complementary corner. If you want to write that down, you can. Corner. Alright, complementary corner. So, these are not going to be set equal. I'm not going to take 4x equals x plus 20. I'm going to add them together to get a certain number. And that's what happens in bunch geometry. You either take two things and you set them equal, or you add them to a magic number, whether it's 90 or 180 or 360. But you add them up to some number. So this one is add to 90. And I want you to actually do that. Take x plus 20 plus 4x and set it equal to 90. Alright, you solve that, you find angle RST. Solve that, find angle RST. Okay, so you got x is 14. When you plug it in, 4 times 14 is 56. So angle RST is 56. Other situation, probably already know where I'm going with this. But on number 3, it's another add to. And the special number now is 180 degrees. Alright, complementary starts with a C, corner starts with a C. This right down here is a straight line. When they make a straight line, straight starts with S, so does supplementary. I will come up with a lot of little things like that for you to remember. Key terms and supplementary, straight line. Supplementary, straight. If you want to write next to it straight, absolutely you can do that to remember it. But supplementary, straight. Alright, so this situation is they add to 180. Well, that's a straight line, so I'm going to add. And again, you can show 2x plus 1 plus 5x plus 4. If they're adding together, I'm fine if you jump into 7x plus 5 equals 180. Whatever you need to do to be successful. When you get to a college level like this, the background work, it's whatever you need to do to be successful. I can get a lot more flexible here than I can with a Algebra 1 class. They need to follow some steps exactly, and I'm looking for them to get some routines down. You've got those routines. You know how to solve equations. So you should get 25. When I plug it in, RST is this one. I'm going to take 5 times 25 plus 4. 125 plus 4, 129. Alright. One other basic idea, and we are done for the day. Well, you're going to have to practice this, but I'm done. Alright. Number 4. Hey, let's even go out of order. Let's start with an easy one. Number 5. How many degrees are on the inside of number 5? 360. Why? Why?
This is a quadrilateral.
Okay, it is a quadrilateral. How many degrees are in number 4? A little trickier there. Alright, here's what I want you to do. Flip it over to the back side. This is a basic idea. This is a very common ACT question. That's not on every single one of them, but it is very common. Always go back to what you know if you forget this stuff. Well, there's a triangle. You know this forward and backwards. How many degrees are in a triangle? 180. Go and write that down. Here's something, anything with 4 sides. Doesn't matter. I kind of drew a kite. Just anything with 4 sides. Well, look at what I can do. I can take a pair of scissors and just cut this guy right here, and I formed 2 triangles. How many degrees are in this triangle? 180. How many in this one? 180. So how many in the total object? It's 360. Let's do that one more time. Let's do any 5-sided figure. Pentagon. I know it's not as easy to draw, but a 5-sided figure. Same thing. Grab a pair of scissors, cut it right here, cut it right there. I got 1, 2, 3 triangles. 3 times 180 would be 540. Alright, there is a formula for that. Some of you guys are remembering that now, and it will work on these. It's the number of sides, take away 2, and you multiply it by 180, because the number of sides minus 2 is how many triangles you can form out of it. So for instance, that's a formula. But again, I forget formulas. If I haven't used that formula in a year, I'm probably going to forget it. I don't forget this. Your brain can easily remember that. Just how many triangles can I make? Oh yeah, okay, I can make 3, so 3 times 180 is 540. But that's why that formula works. Number of sides, take away 2, times 180. Alright? Alright, so on the front side, number 4, I've got 1, 2, 3, 4, 5, 6 sides. So 6 take away 2 times 180 would be 4 times 180, which is 720. Now once again, if this is the first time teaching this in geometry, I may make you actually write out all this stuff. X plus 120 plus 124 plus all that. At this point, I think you guys are capable of adding those numbers up. This would be X plus, if you add up all the numbers, 581 would equal 720. So all I need to do is subtract 581 from 720. X is 139 degrees. That's what that missing angle needs to be. And again, this skill that we're using right here with shapes and figuring out missing angles is going to be a big one we're going to use in the middle of the trig. So let's have you try number 5 and number 6. Okay. Number 5, 3x plus 291, when you add those other sides up, is 360. Subtract 291 from 360 and divide by 3, you got x is 23. Now, I did not ask you to plug that back in, but you do need to watch for that, and I do want to point out the difference. Back up here, this said go find what angle RST is. If I would have labeled this RST and asked you to find that angle, the answer is not 23. I just want to emphasize that. Make sure you are answering the question that they are asking. In this case, find x. Alright, 23, I'm done. Okay? Alright, sum of an interior of a 17agon. Once you get above about 12, a dodecagon, they just put the number in front of it. So a 35-sided figure is just called a 35agon. Alright? So on a 17agon, how many triangles could you make inside that 17-sided figure? Good. It'd be 17 minus 2 times 180. So it'd be 15 times 180 degrees. The interior measure would be 2,700 degrees. Alright. And again, that's been an ACT question every once in a while. Okay. Okay, here we go. Here's the first one. Say whether it be possible. So again, 2 or 3 things that I've not gone over on the note sheet that you do need to see on this one. Say whether it be possible for a triangle with the given sides. Okay, is it possible to have a triangle that has the sides 40, 26, and 10? So I can draw it right here. We'll say this is 40. We'll say this is 20 or 10. A shorter one. We'll say it's 26. Is that possible? Anything stick out about that does not make sense? If I add 26 and 10, if you add your 2 smallest sides, they're not bigger than 40. So that drawing right there could not happen. If you really think dimensionally how this would work, if that's 40, 10 would get you, back like that. 26 would get you, right there-ish. Okay? Even if they are straight across, 10 and 26 add to 36. You're not going to be able to make a triangle. You can't even get them back together, let alone elevate it off of 40 to create a triangle. Alright, so state whether it be possible? No. Just looking for that basic concept, no, it's not possible. And again, it doesn't matter what order they give them in. Look at number 2. Well, 6 and 10, it's your 2 smallest. What are the 2 smallest sides? Alright, those are the ones I'm concerned with. 6 and 8 add to 14, that's more than 10. I can make a triangle. Alright. So number 3, can you make a triangle there? Alright, that's it. Okay. One other thing, you're probably rusty on these. Now, I am not huge on terminology when it comes to college trig. There are some things we need to know, and I will tell you when I emphasize a definition that you need to know. But as far as these go, alternate exterior and interior, again, I just want to refresh you. What I really want to make sure, what comes up in trig, is that you know which angles are equal. For instance, what angle is the exact same as 8? Okay, why? What is the reason of that? What are those two angles called? Well, not only congruent, but in this specific, very good, vertical. That's what I was going for. Good. 6 and 8 are vertical angles. Now it also gives me this right here. That denotes that those are parallel to each other. So because those are parallel to each other, what else is congruent to 6 and 8?
2 and 4.
Good. Number 2 is the corresponding angle to 8. Number 4 is vertical from 2. So if 2 and 8 are corresponding and congruent, well, 2 and 4 are equal because they're vertical, and 4 and 6 are equal because they're corresponding, or 6 is vertical to 8, etc. Okay? Alright, one other little thing I want to throw out, and then I'll have you talk about your table with it, is interior and exterior. This is exactly like a house. Interior and exterior, because these are the parallel lines, this is the interior of my house. So, this is the inside. 2, 1, 6, and 5 are all interior. Alright? Out on the exterior is 3, 4, 8, and 7. So for instance, if they said, are 1 and 5 corresponding exterior angles? No, they're on the interior. Okay? They are equal, they're congruent, but they're not corresponding exterior. That doesn't, alright? So be careful with that. That's exterior, that's exterior. Okay, I think that will be enough. You will have a few questions, and I will answer a few more questions on this at the end of the hour, but that'll be enough that you can work through most of this with your table and get this. And there's some things I want you guys to lead yourself into. So I'm going to give you about 20 minutes to work on it, and give you about 5 minutes of questions in the end.